Friends, I welcome you again for this NPTEL online lecture on earthquake geotechnical engineering. And what we are going to talk is the lecture number 46. That means we already finished 3/4 of this course and last 1/4 we are in the last phase of this course. Here what you have we have the 5th module of the course, which is on slope stability and retaining walls. We already covered 5 lectures on the slope stability, half part of this module is over, and today we are going to start the retaining walls. First of all, retaining walls, and you sometimes it is called RW or then RE walls. RE wall is different than retaining wall. RE wall, in this case you have reinforced earth wall. So do not get confused with retaining walls with the RE walls. In the terminology sometimes it is used RE walls, RE walls. So RE walls are used mostly under the bridges, and that is man made walls, and RE is, although of course it is also retaining wall, but RE stands for reinforced earth walls. So in this, retaining walls are used in the hilly areas. You know, if you go in the hilly areas in the Himalayan region or other, because or let us say in the Uttarakhand, then you passes through near to hills. To protect the hills from falling, you see some walls are there, and that is basically retaining walls. So we are going to talk introduction to retaining walls, then static pressure on retaining walls, then seismic pressure on retaining walls, then we are going to talk the displacement also, seismic displacement of retaining walls, and then finally we are going to talk the seismic design considerations for the retaining walls. So these will be the topics which will be covered in the next 5 lectures, including this lecture. So coming to this first introduction to retaining wall, that is the today lecture number 46. What we are going to talk today in this lecture: first introduction, what are the types of retaining walls and in general, and then we are going to talk about types of retaining wall based on the code IS 14458 part 1, which is published in the last version in 1998. Then next we are going to talk gravity types of retaining structures, and then types of retaining wall failures also going to be discussed today. So let us start from introduction. Earth retaining structures such as retaining walls, basically what is the job of the retaining walls? To retain the earth, it will protect from falling the earth material, and this is used retaining walls, bridge abutments. So retaining wall is a general word, but bridge abutment is also kind of a retaining wall. Then you have quay walls, anchored bulkheads, breast excavation, and mechanically established earth walls are used throughout seismically active areas. So different names are given. So even the quay wall is also a retaining wall, anchored bulkhead is also a kind of a retaining walls. So they frequently represent key elements of ports and harbors, transportation systems, for example as I said, bridges, lifelines, and other constructed facilities. So retaining wall is not only used in the hilly area, they use in near the coastal areas also, where you have the quay walls and other things. They are used, retaining walls, to retain to protect the abutment of a bridge. So it is very widely used. So this is like and this is also based on, because they have also slope. So that is why it is we are discussing after slope stability. Coming to this this part, when we talk about earthquakes, this cause permanent deformation of retaining structures in many historical earthquakes. It has been observed in the past earthquakes that there are permanent deformations. In some cases these deformations were negligibly small, in others they cause significant damage. In some cases retaining structures have collapsed during earthquakes, which disaster physical and economic consequences. The behavior of retaining walls during earthquakes has been discussed in this case. So what are the behavior? So this is IS 14458 retaining walls for hilly areas, and these are the guidelines basically. So there are 3 parts of the code, part 1, part 2, of course there are numbers, it is not only 3, there are I think 14 codes for this this number 14458, but first 3, part 1 and part 2, part 3 are important for us. The part 1 of this code, which is on retaining wall for hilly areas, talk about selection of type of walls. Then part 2, how to design of retaining or breast walls. Part 3, construction of dry stone walls. So we will be discussing the first one today, that is selection of type of wall, and I will suggest that you keep you can download all this code I 14458, at least these 3 parts, and go through those these codes. So, let us say selection of type of walls. When we talk about type of retaining walls, let us talk first in general, then we will talk about what is given in the code. Retaining walls are often classified in terms of their relative mass, flexibility and anchorage conditions. So, when we say stiffness and flexibility, this will be a relative term, because retaining wall is mostly used to retain the earth, soil. Normally the soil compared to the retaining wall, it will be flexible. So, now the how much difference between the stiffness between earth material and the retaining wall, that will govern the design part. And then you have many different approaches to soil retention have been developed and used successfully. Recently the development of metallic polymer and geotextile reinforcement has led to the development of many innovative types of mechanically stabilized earth retention systems. So, what is here? In gravity walls are the oldest and simplest types of retaining walls, which is given in the next figure. Gravity walls are thick and stiff enough that they do not bend. Their movement occurs essentially by rigid body translation or rotation. So, these are the, first of all, they are the simplest oldest walls, and which is given in the the next. Normally these were quite thick or massive walls. So, as a result we can consider that these are the rigid body translation occurs. Certain types of composite wall systems such as crib walls and mechanically established walls are thick enough that they bend very little and consequently often designed as gravity walls with consideration of internal stability. So, here is the types of retaining walls in this figure. The first one is the gravity walls. Gravity wall, you could see the thickness is large compared to other figures A. So, this figure, so the first one is thicker, and when you make thicker, natural thickness will be higher. This is basically cross section, then it is going in the longer direction, longitudinal direction. So, the cross section at the base is larger and at the top it is smaller, which is expected to make for more stability. Cantilever walls are normally thinner, quite thinner compared to gravity walls, but then you could have the base pedestal also, like here in this case. So, naturally this is going to be more stable than the second one. Both are cantilever walls because thickness of their stem is quite small compared to gravity wall. Then you have reinforced soil wall. In this case you are providing some bracings, anchoring, which is going inside the soil earth to protect that wall should not fall due to earth pressure or like this. Then you may have basement walls, so which is given here in the basement, like this is the earth to protect the earth here, and this side you have basement of the very residential building or maybe like. So, this will act. Then you have bridge abutment wall. So, in the bridge abutment wall, this side you have the soil and on another side you have abutment. So, here you could have water or maybe free space on this side. So, one side it protect the earth, another side it could be open or maybe water bodies or something might be there. Then anchored bulkhead. So, this is bulkhead which is anchored on the top and this side. Then tie back wall. So, these are the different types of common types of earth retaining structures used. Coming to the cantilever walls, the cantilever walls we are discussed in detail about gravity walls. Gravity walls are the massive and they are normally do not bend, rather they slide, which we are going to discuss later. Cantilever walls which bend as well as translate and rotate, and the cantilever walls rely on flexural strength to resist lateral earth pressure. Flexural, when the flexural wall comes, it means you bending, it is due to the the bending action to resist lateral earth pressure. Actual distribution of lateral earth pressure on a cantilever wall is influenced by the relative stiffness and deformation of both the wall and the soil. So, when we talk about relative, it means what is the properties of the wall and what is the property of the soil. So, for designing retaining wall, certainly you need to know what is the property of the backfill which need to be retained. Breast walls are constant against a certain type of movement by the presence of external bracing elements. In the cases of basement walls and bridge abutment walls, lateral movement of the tops of the walls may be restrained by the structure they support. So, lateral movement can be restrained. Then you have tie back walls and anchored bulkheads. are restrained against lateral movement by anchors which is embedded in the soil behind the walls. The provision of lateral support at different locations along a breast wall may keep bending moments to be low that relatively flexible structural sections can be used. So, this is like here. So, with this this was in general, but what is like suggested by this code IS 14458 part 1, the different types of retaining walls has been classified based on the types of construction and mechanics of behavior. So, gravity walls we already discussed. In the cantilever wall they says simply rather than driven cantilever walls. Then you have reinforced earth wall. So, as this was the as just I said, this is in the short called RE walls. Then you have the RCC walls. So, the different types are there and the figures are given here. So, like for example, the gravity walls, the first one A. So, in the case of gravity walls it is very massive and at the base the thickness is more, at the top it is less. In the gravity walls, which is according to this code, what you have, let us discuss this in detail. What you have, this line is original ground profile before putting up this wall. Originally there was no wall and this was there. Now what is done, and this wall is normally used to protect some road or like this. So what is done, here this part is cut down and a wall is created here. Now this wall will protect this earth here, which is earth here, and assume Fowler's plane is this one. So ultimately when we want to stability, we need to check the slope stability, this part of this wedge, and this will try to apply the force on this wall, lateral direction as well as. So this wall should be strong enough to resist that earth pressure which is coming from this side. This is cut down. So and then this way it is created. Now another case is tie back walls. In case of tie back wall, looks like a cantilever walls, it is thin, is quite thin compared to gravity walls, and ties are used. These ties will try to keep the wall at its position. Wall panels are there, anchorage are there. So in this case this is one type, inclined anchors. Here you have the horizontal anchors, grouted anchors, bedrock earth anchors in backfill, these all are done here. So third one, driven cantilever walls. So in the driven cantilever walls you have like again very thin wall and assume Fowler plane is here. This is the bedrock, which is like bedrock means you have the quite good condition, stiffness is quite high compared to the soil. Then you on the top of it you weathered rock and soil is here. So this is the original line and this is cut down, this is filled here, this is filled, and then this will protect not only this will protect completely. Then you have reinforced earth wall. In case of reinforced earth wall, what is done? You apply the reinforcement strips are done. So this is the wall, and on this wall reinforcement strips keep at the wall like at in the horizontal direction. So anything which try to like put it down like due to wind action or due to our lateral earthquake force, then these ties will try to keep them in line. Then you have RCC walls, which is shown in this figure. In RCC wall it is reinforced cement concrete wall. So inside the wall the reinforcement is done, that means it is not a plain concrete, rather reinforcement is done, that is why, and the heavy surcharge. But once you provide the reinforcement, then thickness of the cantilever one can be reduced. Coming to the gravity types of retaining structures, normally though it is called retaining wall, but in the hilly areas it is divided in two parts. One is called breast wall, another is simply called retaining walls. Normally the breast walls normally constructed of stone masonry walls and protects of slope cutting in natural ground. So breast wall are used in cutting, but contrary to this, retaining walls are used commonly used in hill roads in partly in cutting and partly in filling. So breast wall are used in cutting only, while the retaining walls are done here, and these are built to resist the earth pressure of filling and traffic roads. So it is here. So this is the figure which shows the difference between the retaining walls and the breast wall. So let us first discuss the retaining wall. Retaining wall is the down one, and in this case to understand it, try to understand the original position. Original position before putting the retaining wall was this. Now what is done? We want to create a road here so we want to protect this this part need to be protected, and because why it is need to be protected, this is a road. So, what is done here? First of all, this part is filled out to provide the stability to the road. Now, what will happen if I do not put a retaining wall, then whatever is filled artificially will again come down. So, a retaining wall is put and this retaining wall will not start from here, it is going quite deep and quite massive. So, it will be even this earth pressure will not try to even the lateral earth pressure, nothing will happen because it is going up to down here. So, in this case this portion will be filled and this portion will be cut down to prepare the retaining wall. So, for the cutting will be done for wherever cutting this was already empty, but this part there was earlier in this part there was a some. So, this will be cutting, this part will be going in cutting and this part will be in filling. So, both cutting and filling is done in the retaining wall and the weep holes are provided. Weep holes are those holes and weep holes inclination is like it is going downward towards the outerwards. And so, weep hole is basic idea of the weep hole is in the rainwater comes out of it, inside earth you may have some water and then this water should percolate and it should come down out of this one. So, this was retaining wall. In case of breast wall you are doing only cutting, no filling. So, you see for like here originally whatever this you have, let us say original position was this. So, you will cut down some material and the to put the wall you have this and this is inclined, this base is also inclined, in this case base is horizontal direction. So, this was about gravity type of retaining walls, which could be the retaining wall simply or it could be the breast wall. Coming to the how the constructions are done and which type is good here. So, there are the same like the retaining walls has been 4 figures are here A, B, C, D, 1A, 1B, 1C, 1D. So, what you have 1A is retaining wall of very small strength, while 1D last one is retaining wall with good filling. So, the last one is the best one, D is the best one and the A is the worst case. Why? In this case you have only face stones are well placed, rest is dumping of stone. So, in this case this has been created just by dumping of the stone without any engineering work or anything. Then you have raised top obstruct drainage. In the second case you have changed, stone layers have been used which is better than the last case sloping outwards, but in the third case you do some shoulder top is shouldered slope. So, and hand here you now have in this case you filled using hand picked stone filling. So, this is done here also it is using hand picked stone filling, but in this case in the D case you are providing toe pitching also, this was completely missing in A, B, C, D, and here the slope is also maintained 1, 2, 3 and this dense soil filling is done compared to what has been done in the C case. So, the D case is the best one out of 4 cases considered. So, further you can go in the detail of these. Coming to the types of retaining wall failures, now let us discuss what types of failures takes place. To design retaining walls it is necessary to define failure and to know how wall can fail. So, it is important that how the failures of the retaining walls takes place. Under static conditions retaining walls are acted upon by body forces which are related to the mass of the wall or by soil pressure and by external forces such as those transmitted by braces. So, you have body forces or you have this mass soil pressures. A properly designed retaining wall will achieve equilibrium of these forces without inducing shear stresses that approach the shear strength of the wall. So, once we design properly then it will be the forces will be equilibrium and there is no issue related. Coming to like during an earthquake, inertial forces and changes in soil strength may violate equilibrium and cause permanent deformation of wall. Why changes in soil strength? Because during earthquake your material goes under nonlinear. Once your material is going under nonlinear phenomena, then the strength of the material may lose during earthquake loading and there could be permanent deformation may occurs. Failure, whether by failure could be by sliding, tilting, bending or some other mechanism, when they occurs when these permanent deformation become excessive. So, when these permanent deformations are excessive then the failure will occur, and there could be many reasons of mechanism of failure. It could be sliding failure, it could be overturning, which we are going to discuss. The question of what level of deformation is excessive will depends on many factors, and that could be decided on site specific basis. Now coming to the gravity walls, that how the types of retaining wall failures, they usually fail by rigid body mechanism because they are massive walls. Gravity walls are massive walls, and rigid body mechanism means, for example, sliding. Mostly gravity walls could fail in the sliding, or they could fail in overturning or by gross instability. Sliding occurs when horizontal force equilibrium is not maintained, that is when the lateral pressures on the back of the wall produce a thrust that exceeds the available sliding resistance on base of wall. Overturning failure occurs when moment equilibrium is not satisfied. Bearing pressure at the base of the wall are often involved. So, you have first sliding failure, or you can have overturning failures. So, in this case of sliding failures, how the sliding failure is taking place? In the typical failure mechanism for gravity retaining walls are shown in this figure. So, in the first figure A, it is sliding, wall is sliding, okay, and in figure B, it is overturning. In the case of rigid body motion, the slide without overturning, but there could be sliding as well as overturning also. So, it could if it is simply overturning, then rather than sliding it may overturn, but there could be slide as well as overturn also. Both it is possible that two phenomena taking place together. So, in this case typical failure mechanism A, sliding or translation failure, second is overturnal or rotational failure, third is gross instability failure where both sliding is taking place as well as overturning is also there. So, it could be possible when you have weak or liquefied layers. So, these type of failures, and these failures are mostly in gravity walls. Coming to gravity walls may also be damaged by gross instability as we discussed. Such failures may be treated as slope stability failures that encompass the wall. Then you have composite wall systems, for example, crib walls, bin walls, and the mechanically stable walls can fall in the same ways by a number of internal mechanisms that involve shearing, pull out or tensile failure of various wall elements. So, the number of mechanism of failure could be one or a number of combination of these two. Cantilever walls are subjected to the same failure mechanism as gravity walls and also to flexure failure mechanism. So, when we have the cantilever walls, you have gravity walls. So, and in addition to gravity wall, because the concept of cantilever walls are based on the what we call flexural, the bending action. So, they also can fail using flexural failure mechanism. Soil pressure and bending moments in cantilever walls depend on the geometry, stiffness and strength of the wall soil system. If the bending moments required for equilibrium exceed the flexural strength of the wall, flexural failure may occur. The structural ductility of the wall itself may influence the level of deformation produced by flexural failure. So, the flexural failure, the structural ductility it will depend on the structural ductility of the wall and it could produce. So, for example, in case of cantilever walls, what type of failure is taking place is shown in the slide. But you have in the first figure A, you have soil pressure. In the soil pressure, and then you have bending moments here. So, this is this failure will take place due to the soil pressure. That means soil pressure exceed the capacity of the wall. So, here the maximum soil pressure will be at this point. Then this is like on one direction compressive, on this side this is active and then passive. Here you have, so it may fail. Then it could be due to flexural failure mechanism. Flexural failure is basically related to what we call the bending moment. If bending moment is maximum, for which the wall is not designed, so maximum bending moment is going here in this case at this point. So, peak value. Then they could also fail this bending moment failure, which is B. Then you have flexural failure mechanism is here, where what is happening, the wall get tilted and this is the maximum is happening at the at the top part of this one. So, depending when we talk about design or failure, naturally the maximum value will govern. In this case it will govern here, in this case this will govern here, this will govern the design. Breast wall usually fail by gross instability, tilting, flexural failure or failure of bracing elements. Tilting of breast wall typically involve rotation about the point at which the brace acts on the wall, often the top of the wall as in the cases of basement and bridge abutment walls. Anchored walls with inadequate penetration may tilt by kicking out at their toes. So, this is like here done types of retaining wall failures. So, this in case of like, and this is basically what is this, we discussed that it looks like a wall of a abutment of a bridge. So, what happens, this was rotated line was the initial position, original position. When it get failed, this could be a deck of this one. So, earlier you know when this was straight, so they were like perpendicular to each other, but now there is a gap because your wall which was like this, now it get tilted like this. As a result you have a gap here, this gap was not there earlier. So, when the wall get failed, so the wall tilted and this may be tilted due to this like more soil pressure at the base, less at the top. Similarly, here this is another, this was gravity wall A case. So, rotation of bridge abutment about top, this is then rotation of anchored bulkhead due to lack of passive resistance, which is called kick out, and this is looks like a cantilever wall anchored, this is anchoring here. So, this anchored bulkhead is done here. So, anchoring is done at the top, but at the base it is free. So, it is done like this was here, it rather than it is not going this direction due to anchoring, rather it tilted, state was this. So, the top portion move inside, the bottom is outside. Then another could be that in this case it was top is moving inside, bottom is out. Here top is moving out, bottom is in. So, this is like a lack of adequate anchor capacity. So, this could be another type of failures. Then we have types of continue with this one. In the case of cantilever walls, anchored walls may fail in flexure, although the point of flexure, what is the point of flexure? Where you get the maximum moment is likely to be different. Then failure of bracing elements can include anchor pull out, tie rod failure or bridge buckling. Then you have backfill settlements can also impose additional axial and transverse loading on bracing elements such as tie rods and tie backs. So, these are all different types of retaining wall failures depending on the type of wall, whether you have the gravity wall, whether you have the cantilever walls, anchored walls, there may be number of failures also. So, with this I conclude this the first lecture on retaining walls, which was an introductory lecture, and then now we will go further in the design part. First we will talk about static, then we will go on seismic. First of all we are going to talk about forces, and then we are going to talk about displacement, and finally design construction. So, with this I conclude today's lecture. Thank you very much for your kind attention.